Hello everybody, welcome to Chapter 2, Lesson 2. This is Brianne Pernick for Robert Morris University Math 0900. In this lesson, we're going to focus on solving equations in the form 1 over x equals b, as well as equations in the form of ax equals b. Now, I added one vocabulary word to this list that is not on the notes that you have, and that is the vocabulary word reciprocal. Please add that to your list and make sure that you are familiar with that term and that you do know what that word means, because it is a word that you need to be able to use and understand the meaning of. Now, as I mentioned, we are going to be working on solving equations that involve both multiplication and division. And what I need you to remember throughout this lesson is that equations represent equal values on each side of their equal sign. With that in mind, we can solve equations that involve multiplication and division by using the opposite operation, very similar to what we were doing with our equations that involved addition and subtraction. So if you guys can look at the bold-faced rules that we have here, when we are solving an equation that involves multiplication, you want to use the opposite of multiplication, which is division, to undo that multiplication. When we are solving an equation that involves division, we want to undo that division using multiplication. So our first set of examples that we are going to work on are equations that are in the form of 1 over a times x equals b. And this is going to call into play the multiplication principle, which says that if both sides of an equation are being multiplied by the same non-zero number, then the results on both sides are equal in value. And we can use this rule the same way that we use the addition principle. If we add something to both sides, that scale remains balanced. If you subtract something from both sides, that scale remains balanced. If we multiply to both sides of our equation is going to remain balanced. If you divide the same number on both sides of your equation is going to remain balanced. Okay, so let's take a look at these two examples that I have here for you. Okay. I do want to show you two different ways to solve these problems, okay? Because many people are going to look at this problem and say, oh, look, I have a fraction, okay? But it's really a division problem, okay? Multiplying by a fraction is exactly the same thing as dividing. Exactly the same thing as dividing, okay? So as you're looking at this, you can do one of two things. If your fraction is in the form of 1 over a number, you can rewrite that as x over 3 equals -15. Because if you were to multiply your 1/3 times x over 1, we would have x over 3. And then what we would say is, well, to undo division, I will multiply both sides of my equation by 3. On the left side, my 3's will cancel, and on the right side, they will multiply to negative 45. And there's our answer right there, with my wonderful little keyboard in the middle that shows up every once in a while. I don't know why it does that. Now, letter B. The second way that I want to show you that involves these fractions is that I want you to remember that I said that multiplying by a fraction is the same as dividing. And when we divide by fractions, okay, let's think back to our dividing by fractions rule. Okay, to divide by fractions, okay, our steps were to multiply by the reciprocal. Okay, do you guys remember doing that? We kept our first fraction the same, we changed our division to multiplication, and we multiplied by the reciprocal. In a problem like this, where you need to undo a fraction, you can simply multiply by that fraction's reciprocal to undo it. And as long as you do the same operation on both sides of your equal sign, your equation will be balanced. So if we take, and I'm just going to rewrite my equation here so that I have some room. That's all I've done so far is rewrite. My fraction is 1/6. I'm going to multiply both sides by 6 over 1 because that is my reciprocal. On the left side, my fractions cancel and I'm left with x. On the right hand side, negative 3 times 6 makes negative 18, and we are finished. Canceling out a fraction is as simple as multiplying by its reciprocal. The next example that we're going to look at is solving equations that are in the form of ax equals b. These examples require us to use the division principle, and it basically says that if we're going to divide both sides by the same number, then our equation will be equivalent on both sides. The result will be the same on both sides. So here's how the division principle works. On the left-hand side, we have 5 times x. And you say, well, I need to isolate my x, and it's being multiplied by 5. To undo multiplication, we are going to divide. So as soon as you say that you need to divide, you are going to draw in 2 fraction bars. What do you need to divide by? 5, because that's what's attached to your variable. On the left-hand side, your 5's cancel, and you are left with x equals 125 divided by 5 makes 25. And you are finished. Let's look at example B. We have 9x equals 60. Your variable is being multiplied by 9. In order to isolate it, you must divide both sides by 9 to cancel out that 9. So we are left with x equals, we have 60 over 9. We must convert that into a mixed number because we should never leave it as an improper fraction. So it will go in 6 times. 6 times 9 is 54. Subtract, and we get 6. So we have 6 and 6/9. The fractional piece of that mixed number will reduce to 2/3. And there we have it. Example C. We need to isolate our x. It is being multiplied by a -3. So we are going to divide both sides by -3. They will cancel on the left, and x equals -16. Letter D. We have -x equals -24. Please keep in mind that a negative variable is not simplified. You must always take that one step further in order to turn your variable into a positive variable. So when you have a negative x, you must recognize that in order to turn that into a positive x, you must divide both sides by a -1, or you can multiply both sides by a -1. Either option will cancel out that negative and make your variable positive. Either option. I would like for you to try letters E and F. Please keep in mind that you may have to combine like terms before you can do anything. Hint, hint. Go ahead, pause the recording, complete E and F. When you are ready, we will come back together to check your work. Okay, at this point you should have solved examples E and F, and you should be ready to check your work with me. For letter E, the first thing that you should have done is combined like terms on the right hand side. 5x minus 8x makes -3x. Then we're going to divide both sides by -3 in order to isolate our x. On the right hand side, the -3's cancel and we're simply left with x. -78 divided by -3 makes 26. Final answer. And letter F. Before you can do anything, you do need to simplify 6x minus 0.8x on the right hand side. So we're going to bring down our 31.2. When we do 6 minus 0.8, we do get 5.2x. We need to divide both sides by 5.2 in order to isolate x. So on the right hand side, we're left with x. 31.2 divided by 5.2 equals 6. At this point in time, we have finished section 2.2. Please feel free to contact me if you have any questions about anything that we have done at all up through week 3 of this course. I will be more than happy to work with you and answer your questions. As always, just send me an email. We can set up a time for tutoring or anything else that would work for you. Please feel free to get in touch with me. Thank you.